Hey guys, this is our FLT here for today for notes number 8. Go ahead and write it down. Given a Taylor-Maclaurin series, I will be able to find the interval of convergence. So notice how it's very similar to the previous lesson. Actually, it's very closely connected, okay? So here's a quick visual. Don't forget what a radius of convergence means. So from a certain center, usually 0, but sometimes it's not. The radius would be how far out you can go from your center, okay? And these will represent all of the x values that will make the series converge, okay? So in the previous lessons, we found out specifically at certain values if it'll converge or diverge. You guys ran all of these tests, okay? But now we're trying to find out a shortcut here. Can we figure out all of the x values that will work? All right. So if you go to the end of each radius from the center, and you go from that start to that end, what that does is it creates an interval of convergence. Okay, an interval from where to where will this series converge, okay? So it's going to be very similar to finding the radius of convergence, but there's a follow-up step to that, okay? So here we go. Finding the interval of convergence, okay? This right here is, the reason why we're spending 2 days on it, or 2 lessons on it, is because it's a huge moneymaker for your BC exam. What I mean by that is you could earn a lot of points with just this one problem, okay? But conversely, all right, you could also lose a lot of points if you don't do this correctly. So pay close attention to the details. Don't try to skip any steps. Do it exactly the way that I show you, okay? And I want you guys to understand that the way that I show you is the most efficient way, all right? So I'm trying to get you to that end goal the fastest way, but showing all the work that's needed, okay? All right, here we go. Here's example 1. Go ahead and write it down. So now we're going to find the interval of convergence instead of just the radius of convergence. Make sure you guys pay attention to that. Certain FRQs will ask you for the radius. Certain FRQs will ask you for the interval of convergence. All right. Of the summation of x to the n over n, as n starts at 1 and ends at infinity. Okay. If you're ever wondering how you read a summation, that's how you do it. Okay, so here we go. First, we're just going to find the radius of convergence, okay? It's the same process, okay? We're going to run that ratio test. And if you need that sheet out, that worksheet, have it out now so that we don't have to go back and forth. What we're going to do is we're going to run that ratio test. Make sure that you guys are running it accurately. Here we go. The ratio test is when you take the limit as n goes to infinity. Here's the number 1 mistake people make. They forget the absolute value bars. Okay, and I'm making it longer horizontally because I'm actually going to skip a step here. So remember, it's a sub n plus 1, so the general term, but the n plus 1 term, divided by the a sub n term, which is just the general term. But if you divide it by that term, you're pretty much multiplying it by its reciprocal. Okay? So we kind of skipped a step there. If you're not comfortable with it, you could write out the 2 fractions divided and then do the step. I'll leave that up to you. But do not forget the absolute values, okay? They play a big role in getting your interval. Okay, so what we do here is, by now, you would understand that x to the n and x to the n plus 1 will reduce out to 1 extra x in the numerator here. If you're still not getting that, please text me or text up here, okay? Okay, so we want this to converge. So we purposely always make it less than 1. All right? Now I take a look at this limit. N is approaching infinity, so the absolute value of x right here has nothing to do with that limit. So you could actually take out that absolute value of x, and then we have the limit as n goes to infinity of the absolute value of n over n plus 1. okay? Okay, so from here, you evaluate your limit, okay? N gets really large, so this is the whole game of where is it getting larger faster, okay? So if you notice here, they both travel at the same speed, so you look at their coefficients, but the coefficients are just 1. So that limit right there should come out to 1. And then I bring down the rest. All right? The absolute value of x times 1 is just the absolute value of x. Okay, here is why the absolute values are so important. You can't just make it reappear, so make sure that you start it off appropriately and you bring it down each time. Okay? If you don't have absolute values, you will not be able to create an interval, meaning a start and an end. When you have an absolute value here, what you do is you create a compound inequality where there's a positive one and a negative one, whatever that value is over here, okay? So there you go. This right here is called the interior, okay? Just the interior interval of convergence. You're not quite done yet, okay? The only thing left in question right now is, can I include the negative one and can I include the positive one? The ratio test doesn't really prove that for us there. So what we do is we have to check it separately, okay? So what we're going to do is we're going to check both endpoints. I'll write it out so you guys can have it in your notes too. Check both endpoints. So what we're going to do is separately, we're going to check what happens when x is negative 1. And then we're going to see what happens when x is positive 1. So if you take a look at the series right up here, we're going to plug in negative 1 for x. So we have the summation of x to the negative, just kidding. Negative 1 to the n over n, as n starts at 1 and goes all the way to infinity. And we'll do the same thing over here. But now x is going to be 1. Okay, so let's take care of positive 1 first. 1 to the n power, no matter how much you raise it, 1 to the any power will just be 1. Okay? And from there, you're going to run your tests out of the 7 or 8 tests that you guys have on that sheet. But you should know what this comes out to, whether it will converge or diverge, okay? Go ahead and press pause there, figure it out, justify it, and then press play. Okay, so you should have said that this series will diverge, okay, for either of 2 reasons, okay? You could say that it's either harmonic, because we know that harmonic series will always diverge, or you could have easily just said p-series test. But I would encourage harmonic series because you guys see that a lot, okay? Now over here, go ahead and try this one out on the left here. Pause and press play whenever you're ready. So you should have said that this will converge for either of 2 reasons, okay? So you could have ran the alternating series test because you have an alternating piece right here. Okay, so we could have said by the alternating series test. You would obviously have to show your work there. So we would take the limit of everything except that alternating piece. We find out that that goes to 0, which is enough to show that it converges by the alternating series test. Or you could easily say that this was an alternating harmonic series. So I told you guys before that these 2 series pop up very often, and it's common knowledge to the AP readers that alternating harmonic series converge. Okay? So what the heck does that mean? We're trying to find the interval of convergence. Okay, so where did it also converge at the endpoints? Okay, it diverged here, so we're not going to include the plus 1. So we'll just leave it as less than. Okay, but at -1, it converged right here. So what we're going to do is we're going to include an or equal to symbol right at -1. Okay, so you could leave it as is, or if you want to get fancy, you could write it in interval notation like that. And then you're all done. Okay. Replay that a couple times, okay? I'm going to show you real quick where you would get your points, all right? So on an FRQ, you would get 1 point for setting this up here, okay? Appropriately. Remember, don't forget your absolute values. You would get another point for evaluating the limit, okay? You would get another point for identifying just the interior, okay? And then you would get 1 point each here for finding if each endpoint will converge or diverge with justification. Okay? If you just say converge or diverge without reason, they won't even look at it. But if you take a look right here, here's 5 points. In some FRQs, they give you 6 points. All right? And you guys remember from last year, your bare minimum that you want to score is about 3 out of 9. So getting a 5 out of 9 is just phenomenal. Okay? All right, so let's try a couple, okay? Go ahead and write that out, and then press play whenever you're ready. Okay, so we're going to run the ratio test. They're asking us for the interval of convergence, so I'm going to run the ratio test every time. I immediately put in my absolute value so I don't forget. This is going to be the n+1 term. So I replace every n with an n+1 divided by the general term or multiplied by the reciprocal. Okay, and I purposely make it converge so the ratio test has to be less than 1. Always, okay? That never changes. Okay, so here I want you guys to go ahead and simplify it. So pause and press play whenever you're ready. And if you're stuck, also press play, okay? All right, so here's the thing. You could cross out a few things. So the easiest ones, 2 to the n and 2 to the n+1, you're going to be left with a 2 in the denominator here. Okay? X plus 1 to the n and x plus 1 to the n+1 will reduce, and you're going to be left with the x plus 1 in the numerator. Now, remember that we're taking the absolute value, right? So this -1 to the n+1 and this -1 to the n technically just goes away, okay? But some of you might have done this, and that's absolutely fine. But remember, if we're taking the absolute value, that negative is just going to go away itself, okay? There are some other scenarios where it's a little bit more technical, and we'll get to that. Okay, so here we go. We're taking the limit as n goes to infinity, so what has nothing to do with it? The absolute value of that x plus 1. Remember, I'm bringing out the absolute value, okay? Not just the x plus 1, times the limit of everything else that was left on the inside. So let's see, I have an invisible 1 at the top and a 2 at the bottom. Okay, I think I have everything here. I'm just double checking. Okay, so the limit of 1/2 as n goes to infinity, well, 1/2 is a constant. So regardless of where n goes, this 1/2 will always be a 1/2. Okay, I'm going to bring everything else down. Okay. So your goal right now is to get the absolute value isolated. So what we're going to have to do is we're going to have to move that 1/2. So we could divide by 1/2, or we could just multiply by 2 on both sides to get rid of that. Okay? So 1 times 2 is just 2. So here's what you guys have to understand. Let me get some space here. So generally, you're going to have an x minus h less than some number, okay? Actually, let me write it like this. Okay? This C right here is your center, okay? So that central point, wherever it is. R is going to be your radius. So this is pretty much how far out you can go each direction from your center. That creates your interval of convergence. So here we have a center. This is kind of like your H backward transformations. Your center is actually at a -1 because it's x minus -1 here. So visually, just to give you guys a picture, your center right now is at -1. Okay, so your center is at -1 and your radius is 2. So if you go 2 units to the right, it's a +1. If you go 2 units to the left, it's -3. So that's how you can get your interior, or more analytically, you create a compound. Again, you cannot create a compound if you don't have the absolute value, okay? So over here is going to be a +2. Over here is going to be a -2. But then you got to do a little bit of work. You got to subtract the 1 everywhere here to get x by itself. Running out of space, but x will be greater than -3, but less than 1, which is exactly what we got here, you guys. So if you're more of a visual person, I encourage you to do it this way. If you're more of the analytical person, the algebraic person, go ahead and do it this way. So you have options, okay? But again, this is just the interior, all right? So what do we have to do? We have to check the endpoints. So we check our endpoints. Here we have -3, and here we have a +1. Okay, go ahead and try that out. Plug in -3 and 1 respectively for x, and then see if you could run a particular test to see if it'll converge or diverge, okay? Press play whenever you're ready. Take your time. Okay, so here if x is -3, okay, then we're going to have -1 to the n times -2 to the n all over 2 to the n, okay? Over here, we'll have -1 to the n, 2 to the n over 2 to the n. Okay, so we'll take care of the easier one first. Okay, on the right side here, 2 to the n over 2 to the n is just a 1. Okay, here we have -1 to the n times 1. I'll write it out so it's not confusing. Okay, what test would you guys run here? Okay, so some of you would probably lean towards the alternating series test because there's an alternating piece. But if you take a look, you could actually run the divergence test. If you take the limit as n goes to infinity, notice how it doesn't come out to 0, which indicates that it diverges already, okay? So remember, that divergence test gets rid of all the easy series, okay? That diverges. Therefore, diverges, okay, by nth term test or divergence test, doesn't matter. Or if you did the alternating series test, but then you would have to show some work there, okay? Okay, so that means we don't include +1, all right? Now over here, there's some algebra to it. Now, I'll highlight it for you guys to see. They both share the same exponent to the power of n. So you could actually combine it. So you could actually combine it as -1 times -2 all to the n power. But -1 times -2 is just a positive 2 to the n power there. Make sure you understood what just happened, okay? Here, 2 to the n over 2 to the n, well, it's the same thing divided by the same thing, so that's really just 1, okay? And same idea, if you run the divergence test, if you take the limit as n goes to infinity for 1, you just get 1, which is definitely not 0, so therefore diverges by the nth term test or the divergence test, doesn't matter. And there you go. So they both happen to diverge. So that means we are not going to include it. So we're just going to say open, -3 to 1 open. Okay. Again, you would get a point for setting it up, for establishing your limit, for creating an interior, and for checking each endpoint with justification. Okay, not that bad once you get the hang of it, all right? Okay, here's one for you guys to try. Go as far as you can before you press play, all right? And then I'll zoom on through. Okay, so hopefully you had enough time. Hopefully you went all the way through, but if you got stuck, it's okay. Here we're going to take the limit as n goes to infinity. Right away, I'm going to put my absolute value bars. So right now, double check your paper. Did you put absolute value bars or did it magically appear later? Okay, hopefully you put it at the very beginning. It's going to be the n plus 1 term. Make sure that you have parentheses there, okay? Times the reciprocal, which is just n squared over x to the n. And we're going to force it to converge, because that's what we're interested in, okay? Okay, so this here will reduce out to just the x in the numerator. Now this right there, n squared and n plus 1 quantity squared, we can't reduce out because they're not factors, okay? But we could do something even better. So what has nothing to do with this limit? As n goes to infinity, the absolute value of x has nothing to do with it. So we're going to leave it out there. And then we're going to keep everything inside of this limit. We have n squared over n plus 1 squared. Okay. So this here, even if you expanded the denominator would come out to n squared plus 2n plus 1. Remember, you're just paying attention to the largest degree. So there you should have gotten a limit of 1. And if you're not sure why, please make sure you text me. Okay. So the absolute value of x here is at 1. Graphically, that means that the center is at 0. And you're pushing out a radius of 1 to the right and 1 to the left. Okay. Or you can analytically create a compound inequality. I'll leave that up to you guys. And there's your interior. Okay. Now we check our endpoints. X is -1, x is +1. So when x is -1, you should get the summation of -1 to the n over n squared, as n starts at 1, goes all the way to infinity. Here it's going to be 1 to the n over n squared. As n starts at 1, it goes all the way to infinity. Okay. Over here, 1 to the n power is just 1. 1 over n squared, you guys would definitely run p-series. Okay. So p-series, when p is 2, I believe it converges. Let me double check. I don't want to shoot myself in the foot here. Okay. For p-series, there we go. When p is greater than 1, we converge. Okay. So converges by p-series. Okay. You cannot get the point if you don't justify it. So if you just say converges, they're not going to give it to you. It has to come with a justification, okay? Over here, I noticed that there's an alternating piece, so I'll run the alternating series test. So I'll take the limit of everything except the alternating part. This here comes out to 0, so let's take a look. The alternating series test, if it comes out to 0, I know it's going to converge. Okay, therefore converges. apply the alternating series test. Okay, so that means we're going to include both of these because they both converge. So that's just going to be bracket -1 to 1 bracket. Hopefully you got that too. But if you didn't, please make sure you ask for clarity, okay? That one we're not going to do. Let's do a couple more, part D. The more practice you guys get in, the more exposure you guys get, the better off you're going to be, okay? Pause here. Go ahead. Go as far as you can, and then press play whenever you're ready. Okay. So here, we want to find the interval of convergence. So we're going to take the limit as n goes to infinity. We're running the ratio test here. Right away, I put in my absolute value bars. Double check yours. It has to appear at the very beginning. Otherwise, you lose out on some points here. I'm going to replace the n with an n plus 1. And multiply by the reciprocal of the general term. Okay, and then I'm going to force this ratio test to converge, so I'm going to make it less than 1. Okay, all right, here we go. So x to the n and x to the n plus 1 will reduce out to just an x in the numerator. 4 to the n and 4 to the n plus 1 will reduce out to just 4 in the denominator. And then everything else here I can't really simplify because I don't have any factors that I can reduce. Okay? Now, we're going to take out what's not relevant. Now here, it's up to you and how you want to do this, but I like to take out everything except for the n's. So even if you took out just the absolute value of x, you would be fine. Okay? Or if you took out the absolute value of x over 4, that would be fine too. Okay? At the very end, your work is going to be the same. So I'm going to go ahead and take out the absolute value of x over 4 times everything else. And again, if you just take out the absolute value of x, that's okay. You're still going to get the same answer at the very end. So here I have n plus 1 times the quantity of n squared plus 1 all over the quantity of n plus 1 squared plus 1 times n. Okay, now although this looks very messy, if you can imagine if you were to distribute the heck out of this, you're only focusing on the largest degree term. So here, that would happen when you multiply these two. That's just n cubed. Okay? Down below, although that gets really messy, I have something squared eventually multiplied by another n. That'll give me another n cubed. Okay? So just by analyzing it, without doing extra work, you should be able to figure out that this limit here comes out to 1. Okay, it doesn't always come out to 1, so keep that in mind. Okay, so the absolute value of x over 4 times 1 is just the absolute value of x over 4. Okay, now the issue here is there's that 4. So you can't do it graphically just yet. So what you're going to do is you're going to multiply both sides by 4 here. Because remember, the absolute value of 4 is just 4. So that's really just this, in which we can just multiply both sides by 4 to isolate that absolute value. Okay? So here's what we have. The absolute value of x is less than 4. What that tells you graphically is that the center is at 0, because there's nothing in the absolute value, and the radius is 4. So I'm going 4 to the right and then 4 to the left. So there's your interval of convergence, or analytically, you create a compound. And there you have it. Okay, this right here is your interior. Okay, now I don't have space, but you guys do, so just write it out the same way you would. But are we done? Right? Most students will forget this last piece, but not you guys because you're awesome. we're going to go ahead and check the endpoints. So -4 and +4. So if you plug it in for x, you should get the sum of n times -4 to the n over 4 to the n times n squared plus 1, where n starts at 4, goes to infinity. So it's a little bit of writing, you guys, but hopefully it's more logical than it is procedural, okay? N times 4 to the n over 4 to the n times n squared plus 1. Okay, we'll take care of the easier one here. On the right side, 4 to the n over 4 to the n will cancel out. N over n squared plus 1. Okay, now, what test would you guys run, right? I would definitely compare it to n over n squared, which is the same thing as 1 over n. Okay, I can't really tell whether it's less than or greater than because both the numerator and the denominator is affected here. So I can't really tell if it's smaller or larger. So what I'm going to do is I'm going to run the limit comparison test. So I'm going to take the limit as n goes to infinity of 1 over the other. So n squared plus 1 over the other. Okay, but remember, you could just multiply by the reciprocal to kind of create a shortcut. Okay, so if you take a look at that, up top, the highest degree you're going to have is n squared. Same thing with down below, so this limit here comes out to 1. Okay, so let's take a look at our test real quick. We're running the limit comparison test. So it came out to 1, which is definitely positive and finite. So we know that they're going to behave the same. Okay, therefore, behaves the same. Okay, I know that this right here is harmonic. Therefore, diverges by limit comparison test. So a little bit of justification here, you guys. All right. Okay. Here you could do this in many different ways. The easiest way to see it, I think, is to split that alternating part. So -4 is the same thing as -1 to the n times 4 to the n. Okay, so this way you can easily see that 4 to the n's will reduce out. I would definitely try the alternating series test because I have an alternating piece here. So I'm going to take the limit as n goes to infinity of everything except the alternating part. I notice that it comes out to 0, and please correct me if I'm wrong. Therefore, it will converge by the alternating series test. Okay, let me double check here just to make sure. There you go, equal to 0, okay? Okay, so all in all, we found out that at -4, it will converge, and at +4, it diverges. So we can only include the -4, but not the +4. So this will be bracket -4, and then 4 open. This is pretty much all of the values you can use that'll make this series converge. Okay? Cool. Let's do this last one, okay? But I'll breeze on through. Go ahead and try this one here, and then that'll be it for the day. And press play whenever you're ready to check your work, okay? All right, here we go. We're going to take the limit as n goes to infinity of the absolute value bars of -1 to the n plus 1 plus 1, or n plus 2. X to the 2 times quantity n plus 1, all over 2 times the quantity of n plus 1, times the reciprocal, 2n, over -1 to the n plus 1, x to the 2n. Now here, it's not too transparent, but 2 times the quantity n plus 1 is really x to the 2n plus 2. All right? A lot of people will kind of forget that. That's why I always write it out. So here, x to the 2n and x to the 2n plus 2 will cancel out, but you're going to be left with a x squared. All right? Since we're taking the absolute values, the alternating parts, or the negative ones, really don't matter because it'll just turn positive anyways. And then we're going to force it to converge. Absolute value of x squared is going to pop out to the outside because it has nothing to do with the limit. And then what's left is going to be 2n over 2 times the quantity n plus 1. If you distributed that out, it really doesn't matter because all in all, that limit should come out to 1 if you did it correctly. Okay, so here is one of those rare cases. Okay, the easiest thing you guys could do, okay, if there are a lot of steps in between that we tend to skip. Now let me show you on the side here. That has nothing to do with the problem. Usually when you guys have this, x squared equals 4, most of you will square root. And then right away you guys will say that x will equal plus or minus 2. Really what's happening here, the step that you guys are skipping is that it becomes an absolute value of x that gives you a 2. And because it's an absolute value, that is what produces the plus or minus 2. So here, even if you were to square root it, it will still come out to a plus or a minus 1. I encourage you guys to just go from here to here. It's not important enough for us to want to dive into detail. But I mean, in short, this is the logic behind it. Okay? Because I know some of you might do this and freak out. Some of you might do this, and then some of you are going to square root, and then you're going to be like, oh no, this is imaginary. So that's really not what happens in between. So just keep that in mind. All right. If you want to know more about it in detail, I can explain it to you in class. Okay. So here's your interior. Okay. We're going from -1 to 1. We check our endpoints. X equals -1 and x equals +1. Okay. So here you should get -1 to the n plus 1 times x to the -2. Sorry, just kidding. Plugged in the wrong value. -1 to the 2n all over 2n. Okay, over here you're going to get -1 to the n plus 1, 1 to the 2n all over 2n. Okay, we'll take care of this right side first here. 1 to the 2n is just 1. So I'm just going to doodle that out because that's just 1. Here we have an alternating series. So I'm going to run the alternating series test. So this is the limit as n goes to infinity of 1 over 2n. Okay, that definitely goes to 0. So we know it converges by the alternating series test. Some of you may have noticed that this is an alternating harmonic. That works too. But some of you may not have recognized that because of the 2. But remember, that 2 can easily go outside of the summation there, okay? Okay. So over here, -1 to the 2n. Okay. If you have 2 times any number, you have to understand that it will always come out even. 2 times any number will always be even. And if you have -1 to the any even power, that always comes out to a +1. So that one's a little bit tricky. So that one's just going to be a +1 there. So over here, you still end up with some type of alternating piece. So it's very similar to what we have over here. So we could just say that it converges similarly by alternating series test or alternating harmonic. You only need to provide one reason, okay? So here we actually included both -1 and 1. So we're going to include it. So that'll be bracket -1 to 1 bracket. Okay, hopefully that's enough practice for you guys to kind of understand the steps. But again, you're earning a lot of points, at least 5, sometimes 6 out of 9, just for this one question, okay? So go ahead and practice, try out the homework, let me know how you guys do, and we'll go from